Environmental Solutions Private Limited and proudly supported by Federation Internationale de Béton, which is also known as FIB. Topic for today's technical session is hydraulic engineering for sustainable watercourse management. In today's session, we have our two panelists, Mr. Stefano Rignanis and Dr. Ratnakar R. Mahajan, along with Secretary and Director General of IEI Major General Dr. Mohanjeet Singh Siali. Now, about FIB. This series, supported by FIB, reflects its ongoing commitment to excellence in engineering, FIB, a not-for-profit association with members in 104 countries, is dedicated to advancing concrete construction technology, economic, aesthetic, and environmental performance. Their contribution through FIB bulletin, events, workshops, and courses are invaluable. Now, a brief about Officine McAfee. Headquartered in Italy, we are a 140-year-old organization with sales spread across 130 countries with more than 3,000 employees, 23 factories, and 70 subsidiaries. MacRA Indian subsidiary was incorporated in 1998 as MacRA Environmental Solutions Private Limited. We are eager to contribute to geotechnical community by advancing knowledge in geotechnical and allied fields of sustainability. We have been associated with some of the most prestigious construction projects across the country. Now, to begin with our session, I would like to call upon Mr. Stefano. Mr. Stefano is a civil engineer and has a Master's of Science in Civil Engineering from Alma Mater Studorium, University of Bologna, Italy. He joined Officine McAfee in 2012 as junior engineer, later becoming technical manager for MacRA Mexico in 2014. In 2018, he moved to USA as technical manager for MacRA North America. Since 2021, he has been based in Italy, working as business developer coordinator for Officine McAfee. Thank you.
Thank you, Mr. Sumit, and namaste. Good afternoon to all of you, and thank you for being here today with us. Let me share my screen, and we will start the technical session of today. Okay, so again, today we're going to talk about hydraulic engineering for watercourses management. In the first part, I'm going to talk about hydraulic engineering principles, and Dr. Ratnakar in the second part is going to talk about some specific solution and applications. Let's start with the webinar, and thank you again for being with us the day today. For me, it's an honor and a pleasure to be here with you. So as Mr. Sumit said, MacRA has a lot of history, so more than 140 years. The very first application, and this is very important to understand, is that a green thought has always driven our engineering mindset, because the very first applications of the gabion historically was in 1894 in order to develop a solution that enhance the protection of the city of Bologna. What was done was to enhance the river ecosystem resilience in order to have to recover from a potential catastrophic event such as a flooding event. And the pictures that you see is nowadays there are still there the protection system that was erected back 140 years ago with the gabions in the city of Bologna in Italy. There is for sure an evolution of this type of applications, because you can understand that, and all of you already know very well, that a gabion solution, normally you can use it for build a mass gravity system, so basically a retaining wall. But during the years, this retaining wall application, it started being used in hydraulic engineering solutions, and also it entered later like an evolution in the MSCW, in the mechanically stabilized arch wall solutions that can be applied also for hydraulic engineering, as you can see from the picture below and in the screen now. Also, the evolution of the gabion itself was the mattress, the Reno mattress. What you see here, you can use it for erosion protection of the river banks, for example. Or another evolution of this solution is the so-called Reno Mattress Plus for underwater installation, where basically you have already the water itself in the river or in the port area, but you can actually pre-fill the mattress in a dry condition, lift it, as you can see in the picture right below, and you can install it underwater. So this is another evolution of such idea, from 140 years ago. But let's talk now about river work principles. Here we need to understand and we need to ask ourselves as civil engineers, as hydraulic engineers, where am I in the design phase? Am I in a planning phase, remediation phase, or we need to we have an emergency and we need to find a quick solution to solve the emergency? For sure, the best case scenario is to be in the planning phase, where you can actually plan the protection of the river, of the channel, and having a sound engineering solution that will last long years. For sure, you can also be in a remediation case where you have, for example, a landslide or a erosion at the toe of a embankment, for example. And so we need to go back and rebuild the bank where was it before the event, but we need to cover it with a better and more sound engineering application and solution. And also you can be in an emergency situation where you need to erect, for example, if you are expecting big and very intense type of flooding events, so you need to erect the bank of the river so you can actually use some emergency application. But very important for the river work principle is to have an idea of the characteristic of the watercourse, because we can divide in three main areas normally the river. For example, it starts from the mountain region where you normally have very steep gradients. So you have not very big amount of water, but you have very powerful water because you have steep gradients, high velocity, high shear stresses applied on the bank. So you can actually have severe erosion and coarse bed load. If we are talking about the mid slope region, so you are actually in the middle between mountain and valley where you have moderate gradients, but you can have actually a higher amount of water for sure because you are collecting more water from the mountain region, and you can have some meandering in this type of area. At the end, the third area is the valley region where you have very low gradients, but you have big amount of water in order to confine and divert, and you need to insert bank protection. As you can see, depending on where we are in the design phase, in which area is the project located, we can consider some solution potentially where you have very high gradients, severe erosion. You can actually try to control the river flow with transversal structures such as gabion weirs in order to try to control the gradient, okay, to minimize the velocity and the shear stresses, and also to protect the bank. Also, if you are in the mid-slope region, you can build small groins, bank protection. And if you are in a valley region, the bank stabilization and erosion control application, and we will have a look to some potential solution. But most important also is the time factor. When we're dealing with hydraulic engineering solutions, we need to understand what is the flood duration, because that can depend on the type of river work or water course that we are talking about. If we are talking about very small rivers or channels, normally the period of the time factor of the flood is less than 10 hours, right? If you are in a medium-sized river, is between 10 and 24 hours. If you are in a very large river, you can go up to 120 hours. So it's a very long duration. Depending on that, the time factor is very important in order to understand what is going to be the resistance that your solution needs to have in order to be safe from an engineering point of view. But also not only the time factor, but also where are we and where the function and the application that we need to have. For example, here you see different type of pictures where you have longitudinal protection of the river, you have a transversal gibbon weir, you have a bank protection and also a groin, depending on where we are along the riverbank. So for sure, if we are along the riverbank, here we need to understand which type of armoring system we need to use. If we have a soft armoring system, an hard armoring system, but also we can have the need to go vertical with an earth retaining structure, for example, depending on the failure that you can have and what was the original bank profile that you need to go back to. For sure, what is very important, in my opinion, is also always to share experience, knowledge, and lesson learned in other part of the world too. Imagine that this was a flood restoration project in France. Here, I don't know if you recall, but back in October 2020, there was a big storm called Alex that caused significant damage in different parts of the country. And the equivalent of a year precipitation, 1 year of precipitation fell in 24 hours. So nowadays we are facing this type of events with more and more frequency, where you have the amount of the same amount of water that normally was falling in 1 year duration in the entire year. Now it's just 1 day it goes down. So this is a critical situation, and those are the results that our, let's say, environment cannot take, because it's something that the design that was done, for example, for this river protection was not considering that amount of water in such short time. So what we need to do now is that we had a very big, huge erosion issue that caused the instability of the bank and the instability, as you can see, of the entire road in this case. So what was done was a bank consolidation reinforced with, for example, reinforced soil structures up to 12 meters high, you can see in the images, in order to control and to have a heart retaining system using the Terra Mesh system or the green Terra Mesh, promoting the vegetation grow, because at the end of the day, what is going to give you a long-term protection is the presence of vegetation, for example. So this is why we're always promoting the use of green solutions in order to decrease the carbon footprint of the overall structure, but also increasing the carbon sequestration in the environment. But also we added the anti-scour protection at the bottom of the structure, because we want to prevent such event to pass again and to happen again in the future. So we added the Reno Mattress Plus and the Gabion structure. Here, today, for sure, we don't have enough time to talk about all the principles, but if you are interested, we are always available to give you additional information on this lesson learned. Also, another possible solution to a big problem that we are facing everywhere in the world. Basically, what we are seeing is that many structures, many embankments are collapsing due to the presence of burrowing animals. So the beavers excavate caves and dikes in the dikes, and that is undermining the stability of the dike. So basically, what we need to do, we need to prevent the burrowing animal to excavate a deep channel, let's say, or a deep excavation inside of the embankment, giving actually a big problem of instability. So we have different options in order to prevent this type of burrowing animal to excavate. So we have two-in-one solution, the anti-burrowing solution, but also we want to control the erosion, and so we promote the vegetation establishment using the Reno Mesh Bio with a coconut fiber blanket attached together with the double twist wire mesh, or the Reno Mesh Green. Basically is a three-dimensional turf reinforcement control mat, high tensile turf reinforcement mat, so the HTRM, as you are familiar with, is a tested performances according to the ASTM standards, impenetrable to the beavers with a long durability of the wire up to 120 years. Also, if we are across the river section, we can have a single vertical drop, a stepped weird in order, as I said at the beginning, where we are in a mountain region, we want to decrease the energy of the river flow. So that could be a possibility to use a stepped weird in order to decrease the velocity, but also the traction force of the river, and also a sloped weird. Those are cross-section, just to give you an idea, and there are manuals how to design this type of solutions for sure. And also, we always promote the integration with nature. This is very important because for us, in McAfee, the green thought, as I told you at the beginning, is what drives us in our engineering mindset, because we want to integrate our solution with nature using natural materials, but the solution has to be easy to repair, flexible, and permeable because of the presence of water. And later we will see. So again, other examples, I don't want to bother you too much, but this show you projects, real case scenarios, and sharing experiences in order to divert, control, and try to prevent such events, catastrophic events, as we are seeing nowadays, with single vertical drop, as you can see, stepped weirds, and slope weirds. Okay, we have different type of approaches, but also with multiple drops. For example, I've been working in different mining applications, storm water type of works that we need to collect the storm water, and we need to do it in a multiple drops with channel linings. So this is something that is very common and can be easily done with a sound engineering approach. Also, if we are across the river, the bridge abutments, this is very important and key to understand that many times we need to prevent the scouring effect that can cause structural stability of the entire bridge in the bridge piers. As you can see, we see many times that the design was done not considering the potential erosion effect long term. So what we need to do, we need to protect the bridge piers or the bridge abutments using hard armoring system. And what is the best way to show you is a case history for sure with hydraulic protection. So here we are talking about, as you can see, is a railway overpass, overpass in a river. Here is explain all the situation, but here is the TGV, so is the high-speed rail in France. And as you can see here, integrated with nature, the solution, the dye protection was used using Reno Mattress and double twist wire mesh gabions. Also, building type of solution that integrates in the environment in order to protect not only the infrastructure, but also the entire community in order to prevent some possible flooding, as I was saying. So this is again a real case scenario. Let's move forward with the drainage solution when we are getting closer to the city centers or to areas with high impermeable surfaces. So when we are developing very impermeable surfaces, so we're getting a bigger amount of water with a high velocity inside our drainage system. So let me ask you, our cities were designed many years ago, not considering the urbanization that we are seeing nowadays. So the problem is that our infrastructure maybe is not designed considering that amount of water that now needs to be drained. So maybe we need to go back and check if, for example, for a small size drainage channel, depending on the shear stress applied to the solution, we have, for example, the underwater, the use of Reno Mattress Plus, while where we have the embankment, we can use the MacRA, that is a high turf reinforcement mat, the high TRM, in order to have the vegetation establishment, for example. Or, and this is another possibility, again, what are the advantages of this solution? You have a rapid growth vegetation. In 3 to 4 weeks, you have the vegetation establishment. It works a barrier against the rodents, as we saw before. You can actually also incorporate percussion-driven anchors, for example, and you don't have any overlaps between the joints. Also, is a medium-sized drainage channel. You can use Reno Mattress Plus, and Dr. Ratnakar will show you later. Also, the meandering control can be done using McAfee solutions, such as you need flexibility. So what are the pillars of this type of application for hydraulic solution? Flexibility and structural continuity. There is a big difference between rigid structures such as concrete or let's say type of structure that cannot accommodate differential settlements, while with a flexible solution you can accommodate this type of situation that considering the use, the presence of water is very common. Also, filtration and permeability and the vegetation establishment, that is very important again from an erosion control point of view, but the most important, in my opinion, is also the environmental friendliness, because you see that during the years, the vegetation establishment is a favorable environment during the recovery stage for this type of solution. Also, environmental friendliness, again, we are enhancing the biodiversity because the bentos can actually live on, in, and near the seabed, river, and lake. As you can see, and we have plenty of examples, including the one that we will see later, with the integration of our solution with the environment. Our experience, in order to conclude my part, we can show you other erosion protection using Reno Mattress Plus in Italy, for example. Those are some data also of the lateral spillway in Loris in France, when was used the Reno Mattress Plus, some information about the design. Also, another one in Romania in order to protect also the culvert exit is very important. Also along in Germany, the railway in order to prevent the beaver to excavate, as we saw from an erosion point of view, and also the bridge pier protection. Again, this is with a very special application of underwater solutions. So I really thank you for giving me the possibility, to talk. Later at the end, we have the possibility to have a Q&A session. So I leave the stage to Dr. Ratnakar. Thank you again for giving me the possibility to be here with you today.
Thank you, Mr. Stefano, for the wonderful presentation we have. So I would like to mention that we'll be taking back-to-back 2 presentations, followed by Q&A session in the end. So now I would like to call upon Dr. Ratnakar R. Mahajan to start with the second presentation of the day. Dr. Mahajan is alumnus of IIT Bombay and working as a regional technical manager at MacRA, responsible for India, Southeast Asia, and Pacific markets. He is a civil engineer with key experience in soil reinforcement, ground improvement, retaining structures, slope stability, river training, channel lining, and rockfall protection. Dr. Atakar, you may proceed.
Thank you, Sumit. Let me share my screen. Okay. Yeah. So I will be speaking about the let's say the sustainable watercourse management. Of course, there are certain parts which has some overlap between whatever Stefano has presented and I have presented. I will be basically delivering the 2 presentations. The first presentation, I'm going to cover the development of a very efficient solution using Reno Mattress Plus, followed by how the efficiency is being measured in terms of its performance, and then the MacRA software for designing the hydraulic structures that we call as the MacRA software suite. That's on our website. We call it as an e-design platform. And for your information, this platform is open and accessible to everyone. You just need to create the login and you can create your own projects and design them. Now, to start with, if you see the history, you will find all the major civilizations, they started with presence of water, where there was a river course or a major water source, all civilizations were around it. Okay, like Indus Valley, or the oldest civilizations you will find wherever there was a water, because water is very essential need for humankind. And of course, watercourse management, that's why it becomes so important. This is one of the biggest challenge in the 21st century. When I say watercourse management, it's not about just drinking water or irrigation water, but associated hazards also. Just now, what Stefano has presented a case from France that the floods occurred in France because of rainfall, supposed to be received in a year, is received in very short span of time. And I think this is very common all across the globe, and you must be seeing this in the news, and India is not an exception. We have every year flooding in the north part of the country. We have floods in south, Kerala is well known now because of the few major disasters. Uttarakhand is not an exception. You have seen the Uttarakhand from, let's say, many years and how the situation is, So this is also one of the highest global risk which has an impact. Of course, when we are looking at ourselves as a hydraulic engineers, we are being asked to design solutions which not only take care of the engineering problem, but of course safety of people, and most important now, the ecosystem. Of course, when we are looking at this, the problem to be solved, not just looking at the today's problem to be solved, but need to take care of the future generations also shall not be get affected, but if they have to be affected in a positive way. Of course, for in this working in this direction, MacRA, of course, we are committed for providing the long-lasting solutions, and this comes through and dedicated effort that is through the innovations. The company started its journey like what Stefano just mentioned around 140 years back. From then, constant investment has been there. The important investment is in our innovation center, which is in Italy. We call it as the MacRA Innovation Center, which constantly works on the innovative, sustainable, advanced products and solutions. Of course, almost over 140 years, the solutions have been developed for river ecosystem, which includes, of course, social ability to recover quickly from catastrophic events, which are usually the floods or natural disasters. Of course, we had coined our campaign in the past, that's the design, the change. Those who have been connected with us must be knowing about this design, the change campaign. Of course, in this for hydraulic engineering, of course, here we are looking at the test campaign for providing the long-lasting economical solutions. Of course, some historical landmarks on the development of the Reno mattress. The first ancestor of the modern Reno mattress developed by MacRA was so-called Mantella Volga, mentioned in historical books, dated in early 1910s, over 110 years ago. It is years later in the early 60s when MacRA develops the Reno mattress as industrially manufactured products since the first applications. Of course, mattresses find an interesting and being flexible and monolithic structure. However, it is only in 1984 that mattresses become an engineered system. So, a manufactured industrial product to engineered system. Why we say engineered system becoming? Because it's being experimentally tested at Colorado State University. That we refer as standard mattresses at that time had a single diaphragm, which makes a partition, and of course it is connected to the base panel using the spiral wire. Of course, few years later, that is in 1990, MacRA decides to industrially improve the manufacture of the mattresses by pleating the base mesh panel in a way to form the vertical partition, resulting in a double wall. For, of course, 2 decades, the new mattresses, so-called Castoro, is designed still using the allowable resistance factor in use for standard single diaphragm, tested in 1984. Of course, that's on the safer side because the product with double diaphragm has better resistance compared to the single diaphragm, but the single diaphragm performance were being used. That's why a new research was taken in 2018 to 2020. Here, the Castoro mattress is allowed to confirm better performance of Castoro type versus the standard type and to introduce new correlation with factors not considered in the past studies. This led to an optimization of the limit performance of new mattresses. The new and modern approach based on the standard method for testing erosion system as per ASTM allowed to upgrade the concept of standard mattresses to a new erosion protection system, the Reno Mattress Plus with X-Ties. The Reno Mattress Plus with X-Ties has basically 3 improvements compared to the conventional standard mattresses. The first, of course, is the pleating of mesh, making the partition more robust and durable. Second, the innovative, much durable new polymer coating Polymac, which make wire more resistance and abrasive effect of sediments carried out by the flow. and higher UV resistance, higher temperatures, as well as much lower temperatures. The third, the very crucial one is the X ties to firmly secure, connect the lead, the top of the mattress to the bottom of the mattress, and these X ties are freestanding tools. This makes them particularly easy to install, and they considerably improve the structural performance of the mattresses against the flow, preventing the movement of the stone inside the mattresses. The ultimate goal of this research was to introduce improvement in a new mattress system which could reduce the total cost of ownership in a riverbank protection. The study was with collaboration with the MIC, that is, of course, MacRA Innovation Center, and the Engineering Research Center at Colorado State University, one of the leading institutions for testing the erosion control system. Of course, the objective of this study posed us in front the challenges like need to review the position of mattresses in hydraulic application, need to provide common approach to the stability in line with the state-of-the-art ASTM, need to develop new ideas to provide and improve the performance, need to provide numerical evidence to the different performance between double and single diaphragm partitions in a mattress, and ultimately with reduced cost of ownership, the need to further raise the environmental value of solution. The research was developed in 4 steps. Of course, the step 1 was aimed to analyzing the effect flow of a wire mesh and the type of partitions only. This purpose, the test was performed running on a flow of empty mattresses. The scope was to see how much resistance the flow would the wire mesh alone would provide. Of course, step 2 and 3 always primary were made, filling the mattresses with rock with different grading and uniformity. Here, combined presence of different partition and stones allowed to test the velocity dissipation through the mattress layer. And the step 4 was made in a larger flume, simulating the real flow regimes in an open channel. Based on the result of the preliminary investigation, the best performing combination partitions and stores were chosen. The tests were performed in line with the requirements of the standard ASTM D6460, which defines the failure either by occurrence of a mechanical rupture or by reaching excessive erosion under the mattress. The development of these phases or the stages required a thorough analysis of various aspects. All research was completed almost in 3 years, requiring important financial investment, but also in terms of the time and resources. On the other hand, results brought up the light quite a valuable outcome, as overall effectiveness of the best performing mattress resulted in 73% reduction of the thickness of a band protection with a conventional riprap. Of course, in a summary, comparing the past present design approach, we can say in 1984 with the first experiment study at CSU, followed by design criteria for stability of Reno mattress, of course with single diaphragm, in line with current design method used for riprap. When I say riprap, in India we refer it as a pitching or a loose rock. The comparison based on the tractive force theory allowed to define the equivalent design coefficient. That's the shield parameter, which is very important for designing these hydraulic structures to apply to mattress protection. This method still in use today for the riprap or pitching is focused on the mechanical stability of the lining, condition of no movement of stone without consideration of potential erosive effects. The development throughout the years of new products along with decades successful projects and experiences mattresses, and lastly creation of a new standard, that is ASTM D6460, introduce a new way to look at the stability of erosion protection system, the mechanical stability combined with the controlled erosion underneath the mattress. This chart shows the summary of the past present results, where we can observe the relevant improvements of mattresses performances when we combine the mechanical stability with an anti-erosion function. The light blue color bars show the results for single diaphragm mattress based on the tractive force tested in 1984. The blue middle bar shows the increase in the shear strength stability when using the double pleated diaphragm. And the dark blue bars show the ultimate and most relevant increase in shear strength when you add the X ties, and overall we have over 50% increase in the performance. Of course, all this information of Reno Mattress Plus, the CSU test of the old ones, the new ones, all this we have updated in our software, that is MacRA software, which is available on our e-design platform. Of course, when we look at this Reno Mattress Plus, which provides the benefits of material thickness reduction, of course, finally, as we reduce the quantity of the materials, the environmental burden, or let's say the impact, is removed or reduced. Installation time, of course, it's being reduced. Most important part is the total cost of ownership. So we are looking at the solution, not just the material part, but its overall total cost to the owner, which of course looked from the perspective of less material, quicker installation, and most important, as India, we want to achieve net zero, as early as possible. Of course, finally a greener result. So just to give a feel of this, if you consider a traditional riverbank protection, considering the loose boulders, riprap, or you may say as a pitching. So for this, of course, you can use the Indian standard IRC 89 for the design. Let's say you may require 1.5 meter of thickness of these stones. Of course, thickness of stones governed by the discharge and the velocity, and usually the Indian standard talks about minimum 40 kg weight stone. Of course, it can be replaced with standard mattresses, which are designed using the performances arrived from the testing in 1984. And of course, now we can look at Reno Mattress Plus as a result of experimental test results, which you have seen in the previous slide. The performance of the permissible shear stress, is quite high. Now, if we just put this in a graphical form, let's look at a thickness of the revetment and compare it with the various shear stresses which will be exerted by the moving water on the soil, which is at the bed level. So you can see here for, let's say, a thickness of riprap around 0.8 meter can be effectively reduced to maybe 0.2 meter thick using Reno Mattress Plus, or maybe 0.4 to 0.5 meter thick of the standard mattress. Of course, in applications with very high flows, that's discharged, and you can say about Reno Mattress Plus is over 73% efficient, more than the riprap or the pitching. Of course, this finally yields in the carbon footprint saving, if we calculate the kilograms of CO2 equivalent per square meter of the bank protection using the riprap or pitching and the Reno Mattress Plus, you will find there is a reduction of around 82%. Of course, this 82% of the carbon emissions are finally yielding into an green solution. Of course, when I'm talking of these numbers, we have taken these numbers from our environmental product declaration. That's the data from where we are getting the information on the carbon footprint. And of course, there are certain assumptions on that, but these are based on the shear stress of 400 Newton per meter square. If you compare the Reno Mattress Plus with the standard mattresses, you can see it's around 28% reduction in the carbon emissions. Of course, when we are looking at this kind of solutions, they are living structures. When I say living structures, basically allowing even the grass, the natural habitat to grow. And you can see the picture of before and after of a project where it's being mattresses being installed, and these structures becomes actually the living structures. So here, of course, the one of the advantage of this Reno Mattress Plus is in terms of not only performances in terms of the shear stresses, but the installation, the double pleated diaphragm and the X-tie makes it relatively easier to install compared to the conventional mattresses. And of course, the performance of those mattresses is further enhanced with the advanced polymer coating as a Polymac, which provides very high abrasion resistance. When we say high abrasion resistance, if you see the current kind of floods you will receive or you observe has a lot of fine particles which basically will have an abrasion over these mattresses. Hence, you need to have a better polymeric protection, which is of course can be achieved using PVC, but Polymac is even further higher performance. Of course, this will need to survive to the current changes in the environment, so chemicals which are present in the water. And of course, if you are using these products in cold climate, need to take care of that. So Polymac, of course, it has very high performance in cold weather. And of course, these products will be exposed to sunlight when you put in the river protection. When you don't have floods, of course, these are exposed to the UV lights. And so again, Polymac provides a better UV protection. Not only performance certification, but also, as I said, the environmental and digital ones are very important. And in order to estimate the carbon impact, carbon footprint, you need to have the environmental product declarations. Now, moving on, I will just switch on to the other presentation of the design, where I'm going to talk about the software MacRA design, MacRA river analysis. As I said, this software is available on the eDesign platform. If you just type eDesignMacRA.com and Google it, you will land on a page where it will take you to this software. In this further, let's say 10-15 minutes, I will take you through the software, basics of software, so that you are able to use this software. Of course, as I said, MacRA river analysis is a suite design software for hydraulic engineering, where it's a new online software. Here, of course, to enter the geometry, all the sections of the user needs to navigate through the window, define parameter, generate plan view, and of course, one or more river reaches. Here, of course, MacRA design runs analysis of watercourses, assuming uniform flow in prismatic cross section and constant gradient. Software allows to choose the type of protection on each segment of the cross section from a database of materials which are already loaded in the software. Of course, these materials available in database, shear stress resistance to the flow is associated, and this allows designer to verify whether the given type of protection is sufficient for preventing the erosion. For the scope of this session, we will only see the MacRA design and design of riverbank protection, open channels. Of course, there are options of the drop structures, but due to paucity of time, I will not cover that. But I will just briefly touch upon that. When I say about the prismatic cross section, this is what typically you may have, like choosing the different predefined cross section templates. The user will just need to adjust or change the length and slope of each segment to adjust to the dimension which are at the site of MacRA design. The geometry of the cross section is made by 7 segments, each allowing with 3 sub stretches. Given the simple hydraulic design, data to be entered are discharge and gradient only. Although simple in its philosophy, the software gained a wide interest in the engineering practice due to its possibility to choose erosion protection system in each segment of cross section, assigning to a shear stress and roughness value each chosen system from the database as mentioned. The second part of the MacRA design software, which will be a subject of course, future discussions, will be basically grade control structure. So probably we will plan a separate webinar on that. Here, of course, the flexible weirs, which are made with the gabions mattresses, are the structures ideally to be designed. But as I said, we will stick to only the first part. Of course, this software allows to check as many flow conditions, design different types of the weirs, sloped, stepped, vertical drop. For each and any of these hydraulic scheme, MacRA design will provide a complete report, including sketch and cross section. The data entry and view of the calculations will be thorough through a user-friendly intuitive graphics interface to assist the comprehension of the formula, design methods. A user guide and technical manuals are also included in the software, and you just click on the extreme right of the software, you will find the manual in the software. Of course, after simple registration to the user, you will have automatically access to all the software features. As mentioned, the data entry is simple and very intuitive. The user shall enter the cross-section dimensions starting from cross-section template. Some basic information about hydraulic parameters such as discharge and average gradient for the cross-section. Ultimately, and most important, the type of material used in the river. The user will have possibility to choose from wide variety of materials. Basically, the protection systems for basically protecting the natural soils or green systems, or either in their initial stage of recovery, that is soil bioengineering techniques, or at their advanced vegetation stage of natural vegetation. Longitudinal structures for riverbank stabilization can be grouped into two main application areas: linings like blankets or turf reinforced mats, meaning the rolled erosion control products, or Reno Mattress serving the function of surface erosion protection. The second category is for the earth retaining system. So it's a completely different in terms of your constructor retaining walls. But of course, here the design will be governed by the hydraulic design, which is different in terms of the design. In terms of the geotechnical stability is a different part, but hydraulic design will be covered here. Of course, the typical examples, if you see, of soft armor linings, either in a small drainage section where you, of course, you have very small flow, or let's say of typical flow regimes where you use softer armor linings like the mattresses, like the synthetic mats like MacRA, which basically promotes the vegetation growth. Of course, these mats can be reinforced with the steel mesh or the polymeric geogrids. They provide an excellent performance as they provide as these advantages. Of course, the use of mattresses in river applications very wide, from typical drainage channels like the streams, which collect and convey water in safe zone, or protection measures in these courses guarantee that the flow is safely brought to a delivery of network. The second category, earth retaining structure, is when they have combined instability. The erosive forces of the water flowing in the river generates a geotechnical instability. In order to re-establish the geotechnical stability of the slope, we can use the conventional gabions, terra mesh, or either system type which is rock filled in front, like green systems can be used. Of course, the improved performance of strong face gabion with stronger and more robust steel wire mesh front exposed surface, providing a better response in terms of the horizontal pressures. Here we can see the examples of applications with different, that's the gabion, terra mesh types, a variety of different locations. All these structures, what you see, like from this part of the world to China to Myanmar, Europe. So all these are from different parts of the world. Here, of course, we can look into the basics, how exactly the design is being considered. Let's look at the cross section of a channel, and where the basic equation of the discharge, which is dependent on the cross-sectional area and the velocity, is being considered. Of course, when we look at the velocity in these open channels, we are looking at the weighted perimeter and cross-section area. From there, of course, we can find out the hydraulic radius R, which is basically cross-sectional area by weighted perimeter. S stands for your longitudinal slope or riverbed gradient. Most important part here is the roughness coefficient. Of course, roughness coefficient depends on the material, like whether it is fine sand, whether it is cobbles, whether it is gravel, clay, whether it's vegetated, unvegetated, mattress, Reno Mattress Plus, or MacMat. Of course, what we have just seen in earlier presentation, the full-scale testing carried out at CSU, the recent one. Of course, it gives the performance parameters. Of course, the roughness coefficients, of course, are being put in the software. That's the table what I just showed in the previous slide is a database. Of course, here we are looking at the shear stress versus velocity. Most of the time, people will be always talking of a velocity. Why we are referring to shear stress? Because the erosion flows follows the principle that the instability starts when the flow becomes critical, generating soil particles to get incipient motion. Critical velocities will depend on the type of soil, water depth, and also from the channel section. So critical shear stress on the riverbed surface will be at the incipient motion equal to the allowable shear resistance of each soil. This criteria of checking the allowable and limit velocity is suitable for regular prismatic channel sections for a preliminary evaluation, while criteria for checking the shear stress is more representative of water effects in typical open channel section where banks are subjected to erosion. Of course, when I'm talking of a shear stresses, we are looking at the water surface, which is exerting a shear on the soil particles. Of course, it will be a function of the depth of the water flow, and of course looking at the hydraulic radius and the gradient of the slope. The shear stress is acting, or the, let's say you can say, hydraulic load acting on the surface at a given point of river bed, tau b shall not exceed the maximum allowable shear of the material in contact with water. That we will, let's say, tau c. Heavy lining materials, tau c allowable shear stress, as well as for loose granular material soil, can be exceeded as a function of the constant parameter, that is shield factor, which can be obtained from the tests. That's what we discussed previously. For erosion blankets, such values of C expressed as a function on time and duration. For other systems, it will have to be obtained from experimental values. Of course, we will have to take care of the criteria that the residual velocity below the geodetic style, shall not again exceed the allowable velocity of the soil particle. Of course, as I said, grade control structure we will cover in some other session. So as I said, the MacRA design, that's what we say, protect the flow of nature, is available on edesign.macaffery.com. Now I would like to quickly glance through some Indian case studies. This is a case study from Assam, where this is, you will not see this as something like a hydraulic structure, but it is a hydraulic structure. If you see on the extreme left, this is the big river, and you can see a nice greenery being developed with the living structures built using a green terra mesh, paralink, and a geotextile. Another example again in Assam. Here basically the very advanced solution in terms of the groins made up of the double twisted wire mesh products are being installed. The purpose, of course, here is for the training of the river. Another example from the state of Bihar. This is Valmiki Nagar. Here the issue was the banks of the river were unstable. There were a lot of erosion. Finally, a solution was adopted using a Reno mattress at bottom, followed by a retaining structure made with the paramesh system, and the slope portion above the HFL was being treated with the MacMat for the erosion control. Is another project from an India region. When I say India region, it's very close by. Ours is like from country Nepal. You can see a very nice groins being constructed using the double twist wire mesh products. Another example of the river training works, which includes the mattresses and gabions from Nepal. One project in the capital, that's in Delhi. That's a Delhi Noida bridge, which is basically connecting Delhi and Noida. So this bridge was requiring a protection, floor protection, and it was a very thick protection, which was optimized almost more than 20 years back using the double twist wire mesh products. Again, going to the northeast on the river Romoria, where mixed of solutions, including the double twist wire mesh, and now you can see the protected bank is completely with the greenery. This is a project from the state of Uttar Pradesh. The river bank, or let's say the ghat, was not so useful before the construction of the structure. What you see in the picture, this is basically ghat which is being developed. For development of this ghat, the strong face gabions and the mattresses were being used. This is very old project, used basically for river bank protection. This is on the river Mahanadi, where it enters the sea. Just before that, at the Paradip, here the Reno mattress and gabions were installed underwater. Another very old project from the state of Gujarat. This is a river bank protection on the river Sabarmati, and fortunately or unfortunately, immediately after construction of this structure, it received once in 50 years flood, and it survived. So with this brief on the, let's say, the river bank protection works, the testings, what's being carried out on the mattresses, the Reno Mattress Plus, the Polymac, and of course, all this know-how is now available in a software MacRA. With this, I would like to really thank Institute of Engineers of India for providing this platform. I think this is one of our last webinar of the series, but I'm really thankful to the organizers for giving an opportunity to share the know-how over a larger audience. Thank you.
So thank you, Dr. Ratnakar, for the illustrative presentation we have. So now with this, we'll be having a Q&A session. So I would like to request everyone to type your questions in the Q&A section. We'll take those questions. So we'll start with Mr. Stefano. And the first question that we have is, what is lifespan of the mesh and how we take care of the erosion?
Thank you for the question. I hear my voice. Okay. No.
Yes.
Okay. So the lifespan, for sure, what is certified from British Board of Agreements, the BBA. So we have 120 years of design life for the durability of the mesh. For sure, this is highly dependent on the type of aggressivity classification of the environment. There is an ISO standard that define the aggressiveness of the environment, so that could be highly dependent on that. For sure, what Dr. Ratnakar said very well is the concept of abrasion. So when we're dealing with the presence of water, normally in the water, the river or the channel, you actually have also some material that is brought through the river, and so you can actually have a big abrasion impact on top of the mesh. So with the use of Polymac, we have a greater performance compared to the commonly used so far, the PVC coating, let's say, that was used so far. So we have a higher resistance for abrasion. That is a very important issue. And also, I believe you mentioned corrosion, maybe, in the question. So basically, the corrosion, you have different type of ways of measuring the corrosion. What is normally done is the so-called corrosion spread test that is actually described in the ASTM A975, where basically you are gonna measure what is going to be the corrosion under the protection, the polymeric protection, after the exposure. And basically you are going to measure that corrosion is less than one opening of the mesh. So that is a possible way on how to measure it. There are different ways, but let me say that, long story short, because again, this is a very nice question, and thank you for asking. But to give you, an answer, this is the answer, the short answer, let's say. So if not, I can continue too much. So let's go ahead with other question, please.
Okay, thank you for the answer. So we'll have our next question. Next question is again from Mr. Stefano. Does MacRA has online training tutorials to design these structures using MacRA design software?
Can you repeat, please, the question? Does MacRA?
Yes. Does MacRA has online training tutorials to design these structures using MacRA design software?
And thank you for Sumit and for the question. Yes, so what we did already during this year, because as Dr. Ratnakar said, we launch on the eDesign platform, the MacRA design software. So you will find actually on our website a special webinar only focused on the use, like a tutorial on how to use the MacRA software. This is one way. The other way is that whenever you go online and you register in the software, you can actually download the technical manual and also the user manual. Is very easy to use. This is the second option, so you can download it and you have the PDF with all the tool. And the third option is that we can actually help you and giving you a special training on the software. Who is interested can ask us, like type, I'm interested, I would like to receive the training session, and we can actually do it for you. So you have 3 ways. Okay. Thank you for the question.
Thank you for the answer. Wonderful option that you have just shared regarding the. So I would request, in case of any training which is required or any, so you would write in the question and answer section. So we'll consider that. So moving on, we'll be having third question from Mr. Stefano, and the question is: what is the MOC of mesh, material of construction of mesh? Can FRP or GRP mesh can be used? And FRP, I believe it is fiber reinforced plastic, and GRP is glass reinforced plastic can be used instead of mesh.
So the answer is that the material is a high tensile strength type of wire, metallic wire. So normally we have different type of coatings on the wire. You can actually have the heavily galvanized wire, so class A zinc. You have galvan wire that is zinc 95%, aluminum 5%, or you can go up to galvan 10 that is zinc 90%, aluminum 10%, and the coating is actually a polymeric coating. Polymac, so that is the standard for us, so is not recommended other type of coatings or as you said, GRP or GFR, yes, the glass reinforced or reinforced. No, actually, we don't need that type of reinforcement. Okay, or maybe I didn't get very well the questions, but no, normally you don't need that. And actually, what we didn't mention, and this is just coming to my mind now, is that there is also the possibility to reinforce like a concrete solution with our double twist wire mesh. So the double twist wire mesh could be the structural reinforcement in the concrete. Okay.
Okay, thank you for the taking this question. Now we'll be moving the question which is asked to Dr. Ratnakar, and question is: what is the ASTM code available for design?
So thank you very much for your question. I think it's a very relevant and valid question. How do we design and what are the standards? But I think now we have an Indian standard to design these solutions. So you can very well take a note of this. The Indian Road Congress has the standard IRC SP 116, which helps to design the gabions and mattresses structures using this approach, as well as Indian Road Congress 89, IRC 89, that's for the bridges foundation. The guideline helps to design various hydraulic erosion control solutions, not only mattresses, but even conventional riprap or anything. Very well, you can compare the design, either conventional riprap or the mattresses. Apart from that, there is an Indian standard that is IS 16014, which talks about the basic material specifications of the mesh. That's the wire galvanization, the mesh opening, tensile strength, the punch strength, and the various aspects, which is basically at par with the international standards like what Stefano just mentioned, ASTM A9750 or BSEN 10223 Part 3.
Thank you, Dr. Ratnakar. So, due to paucity of time, we'll be taking a couple of more questions. And the next question that we have is for Dr. Ratnakar. How to tackle cloud burst by hydraulic engineering in riverbank protection?
Okay, so thank you very much. I think it's a very interesting question. Of course, cloud burst surely is an event which is, I would say, one of the uncertain event, because any riverbank protection, we will have to rely on the data. That's the two types of data. One is the hydraulic data, and of course, second is the geotechnical data. When it comes to hydraulic data, I think if for a certain area, if we are able to predict the amount of discharge is estimated, then probably we would be able to design the river bank protection. The problem is not about designing the bank protection, but the problem here is more of an estimation of an input parameter, because cloud burst, I think, is very difficult to estimate and predict. But assuming if you are able to estimate the flood, then you know the geometry of the area, cross section, longitudinal section of the stream which is going to carry this flow, and from that, of course, we can understand now the driving force, that's basically the shear stresses and velocities. And if these are within the range of the materials which are available, which could resist, then of course we can design the riverbank protection.
So thank you, Dr. Ratnakar. So we'll be taking the final question for today's session. And the question is from Dr. Ratnakar, which is how the mesh is anchored to the banks which has loose soil. Does we need to consolidate the bank prior to installation of mesh?
Okay. Thank you. I think this is very relevant from installation point of view and very commonly being, I think, discussed. Of course, when we look at the river bank, we will need to have a compaction of a soil so that the geotechnical stability of the river bank is first achieved. Once that is achieved, you just need to install the mattresses on the top of it. You really don't need any anchoring. You don't need any anchoring. You just put the mattresses on the slope itself. Of course, for this you need to provide additional length of mattresses on the let's say the horizontal berm on top of the bank itself, which will act as, let's say, anchor point of view. And then you can check from the sliding point of view this whole protection. But if it's a flat surface, that's not really an issue. But of course, many times even the question comes, what's the typical inclination? I have a 60-degree slope, can I put your mattresses, so very steep slopes, we don't recommend the mattresses to be put as a lining. But in such situations, what I discussed earlier, it becomes more than a hydraulic problem or geotechnical stability problem, where we would go for a retention solution. The retention could be in the form of the mass gravity walls with the help of strong face gabions, or maybe a reinforced soil structure using paramesh.
Okay. Thank you, Dr. Ratnakar and Mr. Stefano, for the wonderful presentations that we had today. So with this, we have come to the end of the session, and we hope that throughout our series, it was a fruitful session for you all, as it has been for us. So now with this, we are closing this session, and I would like to call Major General Dr. Mohanjeet Singh Siali, who is Secretary and Director General for IEI, for vote of thanks. Major General Dr. Siali has an impressive Army career of over 36 years, an academic achiever. He holds numerous qualifications, including BTech from JNU, MTech from IIT Kanpur, and PhD in physics. Renowned for his leadership, he provided vital engineering support in challenging terrain like Siachen Glacier and the Northeast region. His role in military operations and as Additional Director General further showcased his expertise, notably advancing the Army's indigenization program. Awarded the Vishisht Seva Medal in 2019 and facilitated as an eminent engineer personality by IEI in 2020. Major General Dr. Siali has been Secretary and Director General of IEI since August 2021. Sir,
Thank
please
you,
take the
Sumit.
lead.
Thank you, Sumit. Esteemed speakers and valued participants, as we reach the conclusion of the fifth and the final session in the IEI Technical Webinar Series on Hydraulic Engineering for Sustainable Watercourse Management, it is my proud privilege to deliver the vote of thanks. At the outset, I would like to extend our heartfelt gratitude to our esteemed panelists for today's session. Mr. Stefano Raganis, please excuse me if there is any pronunciation mistake. Business Development Manager, MacRA, and Dr. Ratnagar R. Mahajan, Regional Technical Manager, ISEAP, India, Southeast Asia and Pacific, McAfee. A special acknowledgement goes to Dr. Mahajan for his invaluable contribution as a panelist throughout all 5 webinars in this series. We appreciate your invaluable contribution throughout the series. Your consistent presence and expertise have provided us with valuable insights on topics like slope retention, ground improvement, geosynthetic solutions to sustainable watercourse management. Our sincere gratitude extends to Mr. Sumit Pathak, Deputy Manager, Technical Marketing, MacAfee, who moderated all 5 sessions, ensuring each discussion was engaging and thought-provoking. We are grateful to MacAfee Environmental Solution Private Limited for their partnership and to Federation International du Béton, FIB, for their support. Together, these collaborations have enabled us to expand our technical knowledge and strengthen the community of engineering professionals dedicated to sustainable development. The enthusiastic response to this series, with over 3,300 registrations and 1,000 e-certificates issued, reflects the relevance of these discussions. The impressive viewership on IE YouTube channel reinforces our commitment to ongoing learning initiatives. Special thanks to the IEI team for their flawless coordination and execution, ensuring each session ran smoothly. To our dedicated participants, your engagement and enthusiasm have truly made this series impactful. Your passion fuels our success, and we eagerly look forward to future opportunities to learn, collaborate, and innovate together. Thank you once again, and best wishes for continued success in your professional journeys. Thank you very much.
Thank you, sir.
Thank you, sir. With this, we conclude today's session, and I would like to say that there is a feedback form in the chat box in the Q&A session section. I would request you to attend that. It will help us improving our upcoming future sessions and future engagements. Thank you all. Have a nice day.
Thank you.
Thank you.